Welcome back, everyone. In this video, we're going to do something very similar to what we did in the last video, which is to rewrite sums and products and so on of fractions as a single fraction. But in this video, the fractions are going to have variables in them. So in this case, these x's are what I'm talking about. Now, everything here works the same as it did in the last video. The algebra is just going to get a little bit messier. But here I am asked to add these two fractions. And so, as always, when I go to add the two fractions, I'm going to need to find a common denominator. That is, I'm going to need to find something that is a multiple of both x plus 1 and x minus 2. And so the thing that's going to work here is to choose as my common denominator x plus 1 times x minus 2. So I'm going to write everything over this denominator. Now, like before, I'm going to need to rewrite both of these fractions as a fraction written over x plus 1 times x minus 2. So I'll do that over here. So 3 over x plus 1, I'm going to multiply that by 1, by multiplying it really by x minus 2 over x minus 2. Okay, and when I do that, I'm going to get in the numerator here 3 times x minus 2, which will be 3x minus 6. And in the denominator, I will get x plus 1 times x minus 2. If I do the same thing for x divided by x minus 2, I want to multiply it by 1 again, but the way I'm going to multiply this by 1 is now by multiplying it by x plus 1 divided by x plus 1. And so I will get x times x plus 1 here in the numerator, which will be x squared plus x. And my denominator here is going to be x plus 1 times x minus 2. And so the point of all of this is that I can rewrite this fraction as this fraction, and this fraction as this fraction. And so when I add these two, if I think of them this way, then what I actually get here is that I'm adding a 3x minus 6 plus, and then an x squared plus x here in the numerator. And so after doing that, what am I going to get? Well, I can collect like terms in the numerator here, so I will get an x squared plus 4x minus 6, and then I will divide that by x plus 1 times x minus 2. Okay. And that is a perfectly fine way to leave the answer. In particular, one thing you might notice is I left the denominator here factored. I did not multiply it out. For everything we do in this class, it will be better to have the denominator factored than multiplied out. So it's fine to give an answer where the denominator is multiplied out, but usually you're creating more work for yourself. So here's my tip. Whenever possible, leave the denominator factored. Okay, so I want to do a couple more examples of variations on this idea, just so that we can practice this and so you can have some examples before you go to the homework and practice it yourself. Okay, so in this example, we again want to put this together into one fraction. And the key here is to realize, like in the previous video, what we have here is a fraction and something that's not really a fraction, or at least something that's not currently written as a fraction. And it will make my life easier if I rewrite this thing as a fraction. Just like in the last video, if I have something that's not a fraction, I can always make it a fraction by writing it as a fraction where the denominator is 1. So I'll rewrite this like this. Now, one thing I want to note here that I had to be careful about when I did this is I had to be careful that I rewrote this as plus and then this minus 2x plus 1 like this. I could not have written this as 4 over x minus 3 minus 2x plus 1 over 1. That would not be correct. The reason why this isn't correct is because now this minus, because I've written this as a single fraction divided by 1, this minus is actually being applied both to the 2x and the 1, because implicitly I have grouped these things together like they were in parentheses by putting them over a common fraction bar. So when you're doing this kind of thing, be extra careful with how you handle your minus signs. Once I have done this, though, I can view this much like the last question. I need to find a common multiple of x minus 3 and 1. The common multiple I'm going to find is x minus 3. So I am going to write this whole thing over x minus 3. Everything's a multiple of 1, so x minus 3 definitely is. Now, what that means is, I definitely don't have to do any work to rewrite this piece of the fraction as living over x minus 3. So this 4 is just going to get copied down to this next line. But this minus 2x plus 1, that I'm going to have to do a little bit of work with. Namely, I need to put this over a denominator of x minus 3. And as we've done before, I'm going to do that by multiplying by x minus 3 divided by x minus 3, which is just 1. Okay. And so this is going to be, and so if I write this out, that'll be minus 2x squared plus 6x plus x minus 3 divided by x minus 3. Okay, and if I write this out slightly more simplified, that'll be minus 2x squared plus 7x minus 3 divided by x minus 3. And so I did that again so that I could move this piece here over this denominator. So this will be minus 2x squared plus 7x minus 3. And so I have one more bit of tidying up and simplification. Namely, I can combine this 4 with this minus 3. And so this will become minus 2x squared plus 7x plus 1 over x minus 3. This is a perfectly fine way to leave this answer. But I might also prefer to put the minus sign in front, in which case then this will be a 2x squared, x minus 3. But note if I want to put the minus sign in front, like what I said earlier, the minus sign is going to apply to every term, not just the first term. So that means I would need to make this a minus 7x minus 1 in order for this to actually work out. Okay. So to repeat, both of these answers are fine. But if you want the minus sign out front for some reason, be sure you carefully pull the minus sign out of each term. This next example harkens back to the first example we did of fraction addition. Namely, we did this example, where we were asked to add 1/4, minus 2/9, and 5/6. So we added these two first, which gave us 1/36. And so we were then adding 1/36 and 5/6. And we needed next to find a common denominator between 36 and 6. And our impulse was maybe to multiply 6 by 36 and use that as our common denominator. But if we paid closer attention, we could notice that 36 is already a multiple of 6, and so we could take as our common denominator just 36, making things no more complicated than they had to be, and giving us this answer. The same thing is actually true in this example. So I might be inclined to say, okay, as my common denominator, I'm going to take x minus 2 times x squared plus x minus 6. But wait a second, before we do that, I want to rewrite this quadratic. Okay. Remember, as I said earlier, it's always nicer to have denominators factored when possible. So before I do anything involving adding the fractions, I might well want to factor this denominator. And if I do that, I'll see that this denominator factors as x plus 3 times x minus 2. And the key thing you want to notice here, before you jump ahead of yourself, is that this x minus 2 is the same thing as this x minus 2. Namely, just like 36 was already a multiple of 6 here, x plus 3 times x minus 2 is already a multiple of x minus 2. So I can take as my common denominator here just x plus 3 times x minus 2. Okay. Namely, I don't have to make this even more complicated by throwing in an extra x minus 2 and multiplying these together and getting some sort of cubic. Once I've made that observation, I just need to rewrite this piece over the new common denominator of x plus 3 times x minus 2. This is already over that denominator, so I don't have to rewrite this at all. But 1 over x minus 2 times, and so I want to multiply it by x plus 3 over x plus 3. And so that will give me x plus 3 divided by x plus 3 times x minus 2, like that. Okay. So that is my new way of writing this fraction here. And so now when I go to copy this down, I'll say, okay, so this is x plus 3 plus, and then this 1, it's already over the right denominator, so I can just copy it down anyway. And so when I add these two fractions, I can rewrite this as x plus 4 divided by x plus 3 divided by x minus 2. A good mathematician is a lazy mathematician. We never want to do more work than we have to do. And so you want to make sure, if you're adding two denominators like this, that you really find the smallest common denominator that you possibly can before you move on. Okay, so our last example for this video, I want to rewrite this sum of two fractions as a single fraction. There are actually two ways I can go about doing this. So the first way is to put these things again over a common denominator. So that common denominator is going to be 1 plus x times 1 plus x inverse. And so when I go to do that, and so I need to rewrite it as 1 over 1 plus x times 1 plus x inverse divided by 1 plus x inverse. And so that will give me 1 plus x inverse over 1 plus x times 1 plus x inverse. And likewise, if I want to rewrite 1 over 1 plus x inverse over this denominator, I need to multiply it by 1 plus x divided by 1 plus x, which is going to give me 1 plus x divided by 1 plus x times 1 plus x inverse. And so when I now go to add these things, I'm going to get that and that. This will be 1 plus x inverse plus 1 plus x. And so if I go ahead and simplify this, this will be 2 plus x inverse over 1 plus x times 1 plus x inverse. And if you follow everything we've done so far, that's where we end up. So that's one way to do this question. And it gets you an answer, and this answer is correct, but it gets you an answer that's not nearly as simplified as it could be. And here's the reason why. When we went to rewrite this as a single fraction, we kind of ignored that there's a secret second fraction here. And we shouldn't ignore the fact that there's a secret second fraction. Namely, the secret second fraction comes from the fact that x to the minus 1 is really 1 over x. And so I'm going to do this question again, except when I do this question again, I'm going to actually make sure I notice that x to the minus 1 is 1 over x. And so my first step here is to rewrite 1 plus x plus 1 over 1 plus x inverse. I'm going to rewrite this as 1 over 1 plus x plus 1 over 1 plus 1 over x. And so before I go any further, I'm going to rewrite this piece in the denominator as a single fraction. Namely, when I do that, what's going to happen, I'm going to get 1 over 1 plus x plus 1 over, and now this 1 is going to get written as x over x plus 1 over x. And so this is going to be 1 over plus x plus 1 over 1 plus x divided by x. And so, if I continue this, this is going to be 1 over 1 plus x plus, and remember, when you divide by a fraction, it's the same as multiplying by the reciprocal. So this is plus 1 times x divided by 1 plus x, which is going to be 1 over 1 plus x over 1 plus x. And so you actually notice here that we ended up with the same denominator. I don't have to find a common denominator between 1 plus x and 1 plus x anymore. And so when I simplify this, I can rewrite this as 1 plus x divided by 1 plus x. But that, in fact, is just 1. Because, well, if I divide 1 plus x by the same thing, I'm always going to get 1. And so that's the key point here. I did this question 2 different ways, but one of them I got this answer, and one of them I got 1. We'd far rather do this question in the way that gets us the answer 1. And so in particular, the moral here is any time you have something to a minus 1 power and you're trying to simplify a bunch of stuff in fractions, you want to rewrite the negative powers as fractions. All right, I'll wrap up there for now, but next time we'll talk about how to solve equations with fractions. But until then, be well.